Today I want to talk about Markov matrices with Python SymPy, and I want to walk you through an example. So first of all, let's define this matrix over here where I set column A to be 0.9 and 0.1 and column B to be 0.2 and 0.8. So what could this mean? This could be anything and describe a transition between two states, or the movement of citizens between two cities, for example. So in our example, let's say we have city A and city B, and we describe the movement of people between these cities. After each iteration, 90% of the people will remain in city A. This is this entry over here, whereas 10% of people will move from city A to city B. And vice versa for city B. For each iteration, 80% will remain in city B and 20% will move from city B to city A. This is what the Markov matrix describes in this case. First of all, we have to set up the initial state, U0, we call it, and define that in the initial state we have 0 citizens in city A and 1,000 citizens in city B. So let me load this. So first we can start with computing the state after one iteration. What will happen? To do so, it's super easy. We just take the Markov matrix A over here times the initial state times U0. So we will have, after the first iteration, there will be 200 people in city A and 800 people in city B. This is just a simple multiplication for this case. Okay. But what do we do if we want to know the state after n iterations? Let's say, for example, after 10 iterations. Here, matrix diagonalization comes into play when you have to do it manually or want to save some processing costs. If you don't know about matrix diagonalization, check out my previous video where I go into the details. But let's assume you know how to take the powers of a matrix. What you can do then is you just get a to the nth power over here. So in this case, we set it to 10, so a to the 10th power. And then we take this matrix and then multiply it with the initial state. In this simple example, we get for city A, 647, and for city B, 352. Okay, and how do we find out what happens after, let's say, infinite iterations? What is the steady state of the system, let's say? This is also easy for Markov matrices because the steady state is always represented, if it exists, it doesn't need to exist, but if it does exist, then it's represented by the eigenvector of the Markov matrix with the value 1. So what we can do is we can get the eigenvalues and eigenvectors of the matrix. So let me first of all load this and print it out. And just using a.eigenvects raw results, we get this back here. It's a little difficult to read. So I'm printing out the single values here. So we get for eigenvalue 1, the one that we're interested in, we get the multiplicity of this eigenvalue. It's only existing once, so this is great. And the related eigenvector over here. And the other eigenvalue would be this one, 0.7, but we're not interested in that one over here. So we know that it exists, it has a steady state, so I just need to extract this eigenvector over here and I can access it with this command. So just access this element over here in the result set. So doing this, as you see, I'm getting this result over here. That's the same eigenvector. And I just write it to the steady state vector. So I call the steady state vector and give it this value. And then let me do the calculations. What I get is over here, I can print out, first of all, this is the unmodified eigenvector, the same one. But what's usually done to understand the steady state is that it's normalized. So we actually doing small transformation here to make it easier to calculate and just say that we get the total. So we're adding these values up and then we're just dividing S by the total to get the normalized values. So they have to add up to 1, basically. Sum of the entries is 1. And then we would have an end result of city A would be 66. and CDB would be 33.3%. That's all I want to show you for today for Markov matrices. See you again in my next video. Thanks, and don't forget to like and subscribe.